This video is on factoring trinomials of the form ax squared plus bx plus c. So this is when our trinomials or our quadratics are in standard form. But we're going to be looking at when the leading coefficient of the quadratic term does not equal 1. Let's first look at an example when the leading coefficient of the quadratic term is 1. When we look at a trinomial like x squared plus 8x plus 15, what we're going to be looking for is two numbers that multiply to 15 but add to 8. So we're looking for what multiplies to c. So it's going to multiply to c but add to b. Remember, we have our standard form of ax squared plus bx plus c. So if I sit and look at the factors of 15, we've got 1 times 15 is 15. 2 doesn't go into 15, but 3 does. 3 times 5 is 15. 4 doesn't go in, but 5 does. It goes in 3 times, which we already have, so we know we've looked at all of the factors already. Now what I'm looking for is which one of these adds to b. Well, 1 plus 15 is 16. 3 plus 5 is 8. That means we want 3 and 5. From here, we know that x squared plus 8x plus 15 is going to factor into x plus 3 and x plus 5. So these two binomials, remember this is a binomial and this is a binomial, are factors of this trinomial. We can also see that with the box. If we make our box, we know we have, given our original trinomial, we have an x squared, and then we know we have 15 1 units. So 1, 2, 3, 4, 5, 1, 2, 3. We've got 15 1 units. So I'm going to have 1, 2, 3, 4, 5 x's, and I'm going to have 1, 2, 3 x's on this side. These are my dimensions of my box, my square, well it's not a square, my rectangle, and that's my factors of x squared plus 8x plus 15. So remember, we looked at what multiplied to c but added to b. Now let's look at when a is not 1, and we're going to take the same idea and apply it to that. In this problem, we have a trinomial of 2x squared minus 5x plus 3. So we have this leading coefficient that's not 1 anymore. However, you're going to factor so similarly. Instead of finding what multiplies to c and adds to b, we're going to find what multiplies to a times c. So in this case, here's my a, here's my c. I'm looking at what multiplies to 2 times 3, which is 6. So what multiplies to 6 but adds to negative 5. So if I look at my factors of 6, I've got 1 and 6. I've got 2 and 3. Now, I need to get to negative 5, and all of these are positive, so I know that they're actually going to be negatives. Negative 2 and negative 3 give me negative 5. What I'm going to do instead, though, I don't know that these are my factors, but what I do know is that I can replace negative 5x with those two factors. So negative 5x is going to become negative 2x and negative 3x. I'm going to leave everything the same, so I have 2x squared minus 2x minus 3x plus 3. This gives me 4 terms instead of 3, and it makes it a lot easier to factor. I'll use the box method to help me. Remember that when we have a trinomial, or in this case, we've got 4 terms, a polynomial, that gives us the area. When we factor it out, that's going to give us the dimensions, the sides. So I know if I have my box, I'm going to fill in my box with my polynomial. So I've got 2x squared, I've got negative 2x, I've got negative 3x, and I've got positive 3. What I'm going to look for now are the common factors of each row and each column. So let's look at our columns first. What do you know is common between both of these? I'm looking for the greatest common factor, the GCF. And what I'm going to notice is that 2 and negative 3, nothing goes into either of those numbers, but I do see that both have an x. So my greatest common factor of that column is going to be x. Now look at this column. We have nothing in here, but we do see that it's not nothing, there still is a 1. Because the leading coefficient, the term with the x, is a negative, we're going to want to take out the negative there. If our negative only landed in the one that doesn't have the x, the non-leading coefficient, we don't need to take it out. So what we're going to see is that we're going to take out a negative 1. We have a GCF of negative 1. Now let's look at the rows. Here I have 2x squared and negative 2x. My leading coefficient is this one, and that's positive, so I don't need to take out the negative. But when we get to this row, because this leading coefficient is the negative, we're going to need to take that out. But anyways, let's look at this row first. We've got 2x squared and negative 2x. I can see that a 2 is common between both and an x. So my GCF of that first row is 2x. In my second one, both of them do not have an x, but they both have a 3. Since the leading coefficient is a negative, I'm going to take out a negative 3. What I now have is my factors of this original trinomial. We have 2x minus 3, and we have x minus 1. And we can write that out to give us the dimensions of our square. Just to be sure, let's double check our answer by multiplying out. If I have 2x minus 3 times x minus 1, what I have is 2x times x, or I'm going to do it with the distributive property, so 2x times x minus 1 and negative 3 times x minus 1. So I'm taking each term of my first binomial and multiplying it by the second binomial. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Negative 3 times x is negative 3x, and negative 3 times negative 1 is positive 3. 2x squared, and then we've got negative 2x minus 3x, which is negative 5x, plus 3. And that is matching to our trinomial up at the top that we started with. If you need to multiply this out using the box method, that's fine. It's going to get you the same answer. And you should always check to see if you did this right. You should pause the video now and try this one on your own using the same tools that we just did. When you're ready, press play again and we'll go over it. Okay. We've got 3x squared plus 11x plus 10. First thing I need to do is multiply a times c. So I've got 3 times 10, which is 30. So I'm looking for two numbers that multiply to 30 but add to 11. So if we go through our factors, we have 1 and 30. That's not really going to do us anything. We have 2 and 15. That's not going to help us. 3 and 10. That's closer, but that's still not going to help us. 4 does not go into 30, but 5 does. 5 times 6 is 30, and 5 plus 6 is 11. So these are our two factors. So we're going to have 3x squared plus 5x plus 6x plus 10. If you want to use the box method, go right ahead. The box method says this is our area, so we're going to place them in the box. We have 3x squared, 5x, 6x, 10. I'm going to first look at what's common between my columns. So I can see that in the first column, I have a 3 and a 6, so 3 is my GCF, and I have an x squared and an x, so I have x. 3x is my GCF. In the second column, I have a 5 and a 10. 5 is the largest number that goes into both, and since there's not an x in both, we can only do 5. It's a positive 5. In the first row, 3 and 5 are both prime numbers, so there's no GCF for that except for 1, and I have an x squared and an x, so I can take out an x. In the second row, I've got a 6x and a 10. So 6x does not go into 10, 6 does not go into 10. We know what else goes into 6 is 1, 3, and 2. We know 3 doesn't go in, but 2 does. 2 goes into 6 and 10, so we can pull that out. And we know it's going to be a positive 2. So these are our two dimensions. We've got 3x plus 5, and we have x plus 2. Let's check our answer by multiplying it out. We've got 3x plus 5 times x plus 2. So I'm going to multiply 3x by my second binomial, and I'm going to multiply positive 5 by my second binomial. 3x times x is 3x squared. 3x times 2 is 6x. 5 times x is 5x. And 5 times 2 is 10. 6x plus 5x is 11x. And I have the same trinomial that I started with. Let's try another. I want you to pause the video and try this problem on your own. All right, let's go over it. We need to multiply a times c, which is 5 times negative 4, which is negative 20. So what multiplies to negative 20 but adds to 8? Well, we've got 1 and 20. We've got 2 and 10, but because this is negative, it either has to be 2 and negative 10 or negative 2 and 10. What I can see is that this one right here, 10 and negative 2, will add to 8. So those are my two factors. I have 5x squared minus 2x plus 10x minus 4. I can make the box. This is my area, so I'm going to write in 5x squared, negative 2x, 10x, and negative 4. I'm looking for what's common in each of the columns. So with 5 and 10, we can pull out a 5, and with x squared and x, we can pull out an x. In this next column, our leading coefficient is negative 2, so we need to pull out the negative. We have negative 2 and negative 4, so we can pull out a negative 2. But we can't pull out anything else because this one doesn't have an x. In the first row, 5 and negative 2, nothing works for that, but we can pull out an x. Notice we don't need to pull out a negative because the leading coefficient is positive. In the second row, we have 10x and negative 4. 2 goes into both of these numbers, so we can pull out a positive 2, but nothing higher. This leads us to 5x minus 2 times x plus 2. And these are the dimensions of my rectangle. Again, if we multiply this out, we can check our answer. So I'm going to have 5x times x plus 2 and negative 2 times x plus 2. 5x times x is 5x squared. 5x times 2 is 10x. Negative 2 times x is negative 2x. And negative 2 times 2 is negative 4. So we have 5x squared. 10x minus 2x is 8x. And we have minus 4, which works. Pause the video and try this problem on your own. All right, we have 6x squared plus x minus 12. So I need to do A times C, which is 6 times negative 12, which is negative 72. So I'm looking for two numbers that multiply to negative 72 but add to positive 1. Now this is a much larger number, so this is a little bit more tricky. We've got 1 and 72. We have 2 and 36. I'm just dividing negative 72 by 2, and I got 36. 72 divided by 3 is 24. So we have 3 and 24. Since we're getting 1, we know that we need two numbers next to each other. So I'm going to keep going. 72 divided by 4 is 18. 72 divided by 5 won't be anything. 72 divided by 6 is 12. 72 divided by 7 isn't anything. That's a decimal. 72 divided by 8 is 9. Now, I need this number to be negative, so one of these has to be positive and one has to be negative. I've got 8 and negative 9, or negative 8 and 9. I'm trying to get positive 1, so I know it's got to be negative 8 and 9. This means we have 6x squared minus 8x plus 9x minus 12. So I'm going to make my box, and I'm going to fill in my area. 6x squared, negative 8x, 9x, and negative 12. I'm going to look at my columns first. What is common between 6x squared and 9x? Well, we can take out a 3 and we can take out an x. What's common between negative 8x and negative 12? We know 2 works, but we also know 4 works. Since this leading term is a negative, we have to pull out the negative. So we're going to have negative 4. We can't take out an x because only one of them has an x. Now let's look at our rows. We have 6x squared minus 8x. I can take out a 2, and I can take out an x. With this next one, I have 9x and negative 12. So I know I can take out a positive 3. And that's going to give us our 2 dimensions. We have 3x minus 4, and we have 2x plus 3. Like usual, check your answer to see if you did it correct. 3x times 2x plus 3, and negative 4 times 2x plus 3. 3x times 2x is 6x squared. 3x times 3 is 9x. Negative 4 times 2x is negative 8x. And negative 4 times 3 is negative 12. So we have 6x squared plus x minus 12. And that matches our trinomial at the top. Here's another example. Pause the video and try this one on your own first. All right, we have 10x squared minus 3x minus 1. So we have to do A times C, which is 10 times negative 1, which is negative 10. So I'm looking for what multiplies to negative 10. Because it's a negative, I need one of my factors to be positive and one of them to be negative. So I have 1 and negative 10. I have negative 1 and 10. I have 2 and negative 5. Or negative 2 and 5. I'm looking for what adds to negative 3x. So out of these options, it's going to be 2 and negative 5 because these add to negative 3. So we're going to have 10x squared plus 2x minus 5x minus 1. This is my area, so I'm going to make my box and fill in my area. 10x squared, 2x, negative 5x, and negative 1. Looking at the columns first, what's common between 10x squared and negative 5x? Hopefully you got 5x. Looking at the second column, what's common between 2x and negative 1? Nothing. But it's not nothing, it's positive 1. We'll never have just nothing. Worst case scenario, if there's nothing in common, you'll always have 1. Now let's look at the rows. We have 10x squared and 2x. So you can pull out a 2x. And in the second row, we've got negative 5x and negative 1. Nothing's common, but this first term, this leading coefficient, is negative. So instead of pulling out a positive 1, I'm going to pull out a negative 1. And this is going to give us 5x plus 1 times 2x minus 1. I'm going to check my solution to see if I'm right. So I'm going to do 5x times 2x minus 1 and positive 1 times 2x minus 1. 5x times 2x is 10x squared. 5x times negative 1 is negative 5x. 1 times 2x is 2x, and 1 times negative 1 is negative 1. So 10x squared, negative 5x plus 2x is negative 3x, and I've got a negative 1, and it works. This is going to be our last example, so pause the video and try this one on your own. All right, we have 3x squared plus 11x minus 4. The first thing that we need to do is a times c, which is 3 times negative 4, which is negative 12. So what multiplies to negative 12 but adds to 11? Because it's a negative number, they have to be one positive and one negative. So we have 1 and negative 12, or negative 1 and 12. Right away, I can see that negative 1 and 12 is going to give me 11. So these are my numbers. So I'm going to have 3x squared minus x plus 12x minus 4. So I'm going to make my box and fill in my area. We have 3x squared, we have negative x, we have 12x, and we have negative 4. Looking at my columns first, I see that I have a 3 that can come out and an x. My GCF is 3x. Looking in the second column, there's nothing common, but I can pull out a 1, and since this first term, the leading coefficient, is negative, I'm actually going to pull out a negative 1. In the first row, we have a 3x squared and a negative x. The only thing we can pull out is x. In the second row, we've got 12x and a negative 4. So the number we can pull out is a positive 4. And there's our dimensions, 3x minus 1 times x plus 4. Last time, we're going to check our answers because it's important. So we have 3x times x plus 4, and we have negative 1 times x plus 4. 3x times x is 3x squared. 3x times 4 is 12x. Negative 1 times x is negative x, and negative 1 times 4 is negative 4. 3x squared, then we've got 12x minus x, which is 11x, minus 4, and that works. Hopefully you have a better idea of how to do this now, but the best way to actually master the skill is to practice, practice, practice. So keep practicing.